Hello scholars, Mr. Masood here with another video with the COSMOS Educational Toolkit. So today we'll be talking about electromagnetic waves. What are electromagnetic waves and how do we use them in everyday life? So let's get started. This is an image of how electromagnetic waves are made. They're made of electric field and the magnetic field, and we will dig into what does that mean and how is it relevant to our lives. So electromagnetic waves are a form of energy wave that have both an electric field and magnetic field. Electromagnetic waves are different from mechanical waves in that they can transmit energy and travel through a vacuum. This is important and we'll go into details about this. Electromagnetic waves are classified according to their frequency. The different type of waves have different uses and functions in our everyday lives. The most important of these is the visible light, which enables us to see. Without the visible light, we won't be able to see each other. This is another image of how the frequency and the wavelength changes. Now, electromagnetic spectrum is the entire range of electromagnetic waves in order of increasing frequency and decreasing wavelength. As you go from left to right, the wavelength gets smaller and the frequency gets higher. This is an inverse relationship. Remember from our previous classes, inverse, like it goes in the opposite direction kind of relationship. This is a video that I want you to watch about what electromagnetic waves are and how they're transmitted through different mediums and what are their frequencies and wavelengths. This video explains in detail. So see the link in the description below, and I want you to take notes while you're watching this video. Now, we talked about visible light. So this is the whole electromagnetic spectrum. And this tiny fraction of this section, this is the visible light. You can see the different colors. And humans are only able to see this frequency or in the electromagnetic spectrum. So our eyes can only see the light transmitted or the waves transmitted in this frequency. Now you have the AM radio, which has a big wave, and then you have X-rays and gamma rays that are smaller waves. Things to remember: the higher the frequency, the more energy the wave has. So AM has small, giant frequency, so the more energy the wave has. EM waves do not require media in which to travel or move, so they can move in a vacuum. EM waves are considered to be transverse waves because they are a mode of vibrating magnetic fields at right angles to each other, and the direction of the wave are traveling. This image from the beginning, they're at a right angle to each other. You know, you have the magnetic field and then you have the electric field, and they're traveling at a 90-degree angle to each other. There is an inverse relationship between wave size and frequency. As wavelengths get smaller, frequency gets higher. Now let's talk about radio waves. Radio waves have the longest wavelength and the lowest frequencies. Wavelengths range from thousands of meters to 0.001 meter. So the radio waves have the longest wavelength and has the lowest frequency. So now we move on to infrared waves. They have the shortest wavelength and therefore they have the higher frequency. Our visible light that allows us to see has a wavelength range of 700 nm red light to 30 nm violet light, which with frequency higher than infrared waves. These are the waves in in the EM spectrum that humans can see. Visible light waves are a very small part of the EM spectrum, as we discussed. So you have your radio waves, you have your microwaves, infrared, and this section is called the visible light. And then you have your ultraviolet, X-rays, and gamma rays. And we are only able to see the small section of the entire EM spectrum. Ultraviolet light waves lengths range from 400 nm to 10 nm. The frequency, therefore, has high energy. It's high enough with UV rays to penetrate living cells and cause them damage. So sometimes when you go out onto the beach, you're scared of ultraviolet light because it can penetrate to your skin cells and cause cancer. UV rays on your skin produces vitamin D in our bodies. Too much UV can lead to sunburn and skin cancer. So that's how you get sunburn on the beach. UV rays are easily blocked by clothing used for protection. So if you cover yourself with sunblock or with clothing or with an umbrella, you'll be safe from the harmful effect of ultraviolet light. Now, X-rays are another type of waves on the electromagnetic spectrum. X-rays wavelengths from 10 nm to 0.001 nm. These rays have enough energy to penetrate deep into tissues and cause damage to cells as well. They are stopped by dense materials such as bone, used to look at solid structures such as bones and bridges for cracks, and for treatment of cancer. So it can penetrate through the cells, but it cannot penetrate to the bone. So that's why when we take an X-ray image, you can see our skeleton, you can see our bones, but you cannot see our cells. So if you ever get injured and you get an X-ray taken, that's because the wavelength of X-rays are such that it can penetrate through our cells, but not our bones, therefore allowing us to take an image. Now, gamma rays carry the most energy and have the shortest wavelengths, less than 1/1,000,000th of a meter. Gamma rays have enough energy to go through most materials easily. You could need a 3 to 4 feet thick concrete wall to stop them. Gamma rays are released by nuclear reaction in nuclear power plants, by nuclear bombs, and by naturally occurring elements on Earth, sometimes used in treatment of cancer. So gamma rays has the most energy and the shortest wavelength. This picture is a scintigram. It shows a asthmatic person's lung. The patient was given slight radioactive gas to breathe, and the picture was taken using a gamma ray camera to detect the radiation. The color shows the airflow in the lungs. Now, in summary, electromagnetic waves are energy waves that have electric and magnetic fields. These waves travel through a vacuum and can transmit energy. Each type of electromagnetic wave is used for a different purpose. They are also classified by their frequency, the length of the wave, speed, the crest, high points, and low points of the waves. The higher the frequency, the shorter the wavelength. This was a lesson on electromagnetic spectrum. So if you have any questions or concerns, please write it to us and I will love to respond back to you. Once again, this is Mr. Masood signing off for COSMOS Educational Toolkit. Goodbye.